the system of the Primordial Wheels. Here it is in all its glory. It is a 6 score. And there is, many different like there's many things going on here. First of all, it's 6 score. That means, when you get to 120, what I got there, I made the 0 special. Note to anyone who wants to make a very interesting number system, make the 0 represent what you're trying to represent. So, if you use a base 6, a cool idea would be to use something like that. If you use a base 5, use a shape that not necessarily is 5, because that could be cumbersome, but use something that has like a 5 nature in it. You could use maybe a star or something. If you use a base like binary, you could just make, one big line and one little line, right? Because there's only 2 sides of a line. Here's what I got going on here. We got the 1s, 1 through 4. The 5s are a little bit, complicated, but they're sort of side with this way, and this number system does get quite cumbersome after a while. But it's a pretty good representation of 120 if you don't mind, making a couple extra strokes. You got 6, which is 5 plus 1, 7, 5 plus 2. 8, 5 plus 3, 9, 5 plus 4, and then you get 10, which makes a loop. You know what I'm saying? And the reason this loop is here is so you won't confuse this. This and this can't be confused. They're 2 different things. This represents 5, and this represents a score. So basically, what you got going on here is this is a base 120, and this whole place together is like a base 120, or like a 120s place, and this is like a 0, and this is based on Koviak. I finally found one that works really good. See, now this thing, I'll be uploading this to a channel base 120 multiplication. Or base 120 whirly, I might call it. But you can see you got 1, 2, 3, 4, 5, 6, right? 6 score. This is 120s place, but there's 3 places in this 120s place. Do you know what they are? There's the 120th place itself. Then there's the 600s place, believe it or not, because actually 6 times 5 is 600, and there's 3 of those. And then, here you just count the lines. 1, 2, 3, 4, 5. You see how there's 5 lines there, even though it's 3 fingers? That represents 5. Okay, and that's how many, you can always count, how many strokes there are. 1, 2, 3, 3 score. You see what I'm saying? 1, 2, 3, 4, 4 score. 1, 2, 3, 4, 5, 5 score. So you got 5 score there, and it is in the 2400s place, right? And then you got 4 in the 120 place itself. So when you add all that up, that ends up being 119, which multiplied by 120 equals 14,280. So, for all those people interested, this is as close as I could get to a Koviak system. I mean, I tried and tried. I mean, I tried on and off. I didn't, spend all my days living working on this, but I figured that since you know, 120 is such a convenient number, and, you know, there's so many good benefits of it, you know, and it was even considered a long hundred at one time. It was very useful in, you know, the Middle Ages and stuff. I just decided, you know, fuck it. I mean, I'm gonna make a base 120. It's, you know, it's badass, and you know, that's just really cool. It's a really cool idea, I think. You know, you're sort of, you know, counting the number this way, or you can add them all up in the other direction, right? You can add them up in any way you want. But when you add all of it up, and then you look at what place it's in, that tells you what you got, you know? And, you know, of course, you know, if you wrote another zero there, you'd have 14,400. If you wrote another zero after that, you have 1,728,000. All this amazing stuff, and I need to still learn algebra. Yeah. So, good day to y'all. Hope you learn from this as best as you can. And I'm out.